Okay, so this is form 2 of our SMART goal from last week. You guys will actually get your grades recorded on this starting tomorrow. You guys will be tested on reflections, translations, and rotations. For sure, a total of 3, maybe 4 times before then I'm going to stop. And if you're not happy with your SMART goal grade, you'll have to pursue me before school, after school, maybe during lunch one day. But anyhow, we're going to perform some reflections across prescribed axes. So here it says across the y-axis. So you need to first identify where is the y-axis, and here it is. So I want to look at each point individually. Guys, this process is not meant to take a long time. I noticed that some kids did spend, I don't know, 10 minutes or so, like the entire last bit of class doing this. This should be able to be done very quickly. So you identify the axis in which you're doing your reflection, either across, in, or about. So those words, we could say across, in, or about. They all mean the same thing, that we're reflecting around this axis that was prescribed. So here's my y-axis. I'm going to take my point y. I notice that it's 1 unit to the right of my y-axis, so y prime is going to be 1 unit to the left. I'm going to do the same thing with all of the other ordered pairs. Z is 3 units to the right, so Z prime is going to be 3 units to the left. Now I'm done with Y and Z. I'm going to go ahead and look at X and W. X is 1, 2, 3 units to the left, so X prime is going to be 1, 2, 3 units to the right. And W is 2 units to the left, so W prime is going to be 2 units to the right. I have to connect the dots, otherwise I did not actually finish the job. Okay, so now my figure has been reflected across the y-axis. Questions? Okay. Number 2, again, it says reflecting across the y-axis. Whoops, let me scoot down a little bit. I'm going to change the instructions here, though, just so that way you guys can have another example that is different. We're going to go across the x-axis, mainly for video purposes. Okay. So I want to identify where the x-axis is. And there it is. And then every single point for my figure, I want to reflect it across that axis. So I see L is 2 units below, so L prime would be 2 units above. I see K is 2 units below, so K prime is going to be 2 units above. And I see that J is 4 units below, so J prime is going to be 4 units above. Connect the dots, and we are finished. Okay, now I did change the instructions on this mainly just for the video purposes. Okay, we have numbers 3 and 4 where it's asking us to perform these reflections, but this time we don't have a coordinate plane. And I had some kids ask for graphing paper, and I did not give out graphing paper for those. I told them if you want to take the time to draw them yourselves, you can, but I would need you guys to be able to do these reflections without graphing paper. So if we're reflecting across the x-axis, then x stays the same, or our x values stay the same. And our y values are negated. Yes, ma'am? Okay. All right, thank you. Bye. Okay, so while I was on the phone, I went ahead and kind of started prepping up my prime points. Whenever we do these reflections, it's important that you actually annotate by using that prime notation. If you don't use prime notation on your test, you're going to lose half credit for that. Okay, so you need to make sure you're using prime notation, and obviously the order pairs need to be right as well. But anyhow, if I'm reflecting across the x-axis, my x values stay the same, but we're going to negate our y values. Oh my goodness, I don't really have a lot of space. You know, let me go up here, y values. Okay, so my x values, they're all going to be the same. So I went ahead and just copied them down. Now my y values are going to be negated. I've got 0, so 0 is just 0. I have positive 3 here, so positive 3 becomes negative 3. Here I have a positive 4, so that's going to become negative 4. And over here I have a positive 5, so that's going to be negative 5. Okay. Number 4, it says a reflection across the y-axis. So y stays the same. x values are negated. So I'm going to have p prime, I'm going to have q prime, I'm going to have r prime, and I'm going to have s prime. I went ahead and just kind of filled out these little templates to fill in my values. Again, we are reflecting across the y-axis, so our y values stay the same, our x values are negated. So I'm going to go ahead and copy in all of my y values. And now I'm going to negate those x values. So the opposite of 0 is just 0. The opposite of positive 2 is negative 2. The opposite of positive 5 is negative 5. And the opposite of positive 5 is negative 5. You're just going to have to memorize those rules in order to do these reflections. Okay, numbers 5 and 6, we are doing translations. I'm going to show you guys two ways to go about it. We can do it algebraically, or we can do it graphically. The instructions say graph the image of the figure using the transformation given. And then I have some notes for you guys that the appropriate translation vector grouping symbols, they were not available in the program that I used to build this. And so, the translation is indicated using parentheses rather than those little pointy brackets. But to do this algebraically, we're simply going to add those corresponding components. Notice it does not tell us to graph the pre-image, so we're not having to graph those original points. It's asking us to graph the image. So k prime, its x value is going to be k's x value plus the translation vector's x value. So we're going to have negative 5 plus 3, which is negative 2. For the y coordinate, we're going to have 0 plus negative 5, which is negative 5. Okay, for j prime, we need to add negative 5 to 3. So what is negative 5 plus 3? Negative 2. Okay, and then for the y coordinate for j prime, we need to add j's y value to the translation vector's y value. So what's 5 plus negative 5? Okay. And then a prime, we need to add those corresponding components. So a's x value is negative 2. The translation vector is x value is 3. What is negative 2 plus 3? Okay, and then the y values, we've got that positive 3 plus a negative 5. What is 3 plus negative 5? Okay, so you do the math to get the ordered pairs. You plot the points, connect the dots. So k prime's at negative 2, negative 5. Starting at my origin, I'm going to go back in the negative x direction 2 units, and I'm going to go down 5. So there's k prime. I've labeled my point. Oh, you guys can't see it. There we go. J prime is at negative 2, 0. So starting at the origin, I'm going back 2, and I don't go up or down at all because my y coordinate is 0. So there's J prime. And then A prime, that's at 1, negative 2. So starting at the origin, I go over 1, and then I go down 2. And there's I prime. I go ahead and connect the dots. And I'm finished. There's my figure. Now that's all that was required at the bare minimum. Let's say that you did not remember how to do the translation part algebraically without, graphing your original image. You could have graphed your original image, and I did notice that a lot of kids actually did it this way. So I'm going to go ahead and plot these points. I've got M, L, K, and J. So M is at negative 3, 2. L is at negative 1, 5. K is at negative 1, 4. And J is at 2, 1. I'm going to go ahead and connect the dots. This is going to be a interesting looking quadrilateral. Okay, so here's my figure. Now, that's my pre-image. It did not tell me that I needed to graph my pre-image, but some kids chose to graph their pre-image, and then they chose to honor the translation. So the translation is negative 1, 0. And so remember, your translation vector is telling you how many units to the left or right you're sliding for that x value. And then the y value tells you how many units up or down that you are sliding. Okay, so I'm going to look at each point individually and honor this translation. So starting with point M, I need to go back 1. So here's M prime. Starting with L, I need to go back 1. So here's L prime. With K, I need to go back 1. So there's K prime. And with J, I need to go back one. So there is J prime. I'm going to connect the dots. I'm going to go ahead and kind of shade it in. And so there it is. There's a translation that's been graphed, without doing the addition. I think the addition part's easier, but sometimes it's better for kids to see that visual slide happening. Okay, questions? Okay, Anna, how about you? Because you were out last week. You got any questions?